A group of boys and girls went to the movie theater together. The cost of the movie was $10 per boy and $5 per girl. The total cost for the night was $100. The movie was so good that the next night the same group of boys and girls went. This time it cost $10 per boy and $4 per girl, and their total was $90. The question is, how many boys and girls went to the movie each night? So what we're going to do here is we're going to solve a system of equations using graphing. Now there's various ways of solving systems of equations, but for now we're going to learn how to solve by graphing. Systems of equations means that we've got two equations in the problem, and we need to find a solution that works for both equations. Okay, so the first thing I'm going to do is identify what my two equations are. So the first important information here is the cost of the movie was $10 per boy and $5 per girl, and the total cost was $100. Okay, and then the next night the cost was, that. Next night was $10 per boy and $4 per girl, and the total cost was $90. Okay. All right. So the first night, our equation would be 10 boys, $10 per boy. So if there was 3 boys, it would be 3 times 10 to find the cost. So our equation is going to be first night is 10b, 10 times $10 per boy, plus 5g equals a total of $100. Okay. Now we can solve this equation by just plugging in a number for the boys and then figuring out how many girls there were. There's several possible answers for this problem. So we're just going to make a little chart here. Okay, here's our boy answers and our girl answers. So for instance, if there were 10 boys, well, that would be 10 times 10 boys. That would be 100 plus what equals 100? Well, that means that there must have been 0 girls, because 100 plus 0 is 100. So if there were 10 boys, there's 0 girls. Okay, if we plugged in 5 for B, 5 times 10 is 50, which means there must have been 10 girls. And 0, if there were 0 boys, then that would be 20 girls. Okay, so we're going to do the exact same thing for the second night. Second night, there were it was a cost of $10 per boy again, 10b, plus this time it was 4 per girl, and the total cost was 90. Okay, so again we'll make our B and G table. So if there was 1 boy, plug it in, and that would mean that there were 20 girls. 3 boys, there would be 15 girls. if there were 5 boys, there would be 10 girls, and 9 boys, there would be 0 girls. Okay, so we have several, again, we have several possible answers for the second night as well. So we obviously need to find the number of boys there were that was a possible solution for both nights. Okay. Well, we're going to graph these two lines. We're going to graph these 2 lines, and so our first night, we notice we have the boys, number of boys on the bottom. That's our x value. So our b is our x value, and the number of girls on our y value. So the g is our y value. Okay. The first night, the equation was 10b plus 5g equals 100, and we said that if there's 10 boys, there were 0 girls. We said if there was 5 boys, there were 10 girls, and if there were 0 boys, there was 20 girls. Oops. Okay, and if I were to draw a straight line here, okay, I'd graph my equation. Now the second night, my possible solutions were if there was 1 boy, then there was 20 girls, and 3 boys, 15 girls, and 5 boys, 10 girls, and 9 boys, 0 girls. Okay, you can see we have a slope of down 5 over 2, down 5 over 2, down 5 over 2, and if I were to connect these dots, we can see that the solution that works for both equations is 5 boys and 10 girls. Therefore, our answer to the question is 5 boys and 10 girls.